Okay, you can see the values that I got when I plugged these all in. If you struggled getting these, please make sure that you ask for clarification. But pause the video, write them down if you got them wrong so we can talk about them a little bit. Now let's graph them together. Again, please pause the video. So you're going to write down your videos, you're going to write down the values, pause the video, you're going to plot your points, and then start the video again. Okay, please check your points with mine, make sure that they match. And then let's move on to the got it. Again, if you have questions, be sure that you ask when we come back to class. We're going to talk about the asymptotes of the got it, and then we're going to pause the video just like you should have above. Alright, so let's first talk about the vertical asymptote, and that comes from right here. I'm hoping you know that x plus 3 is not allowed to be 0, so x is not allowed to be negative 3. That means there's a vertical asymptote where x equals negative 3, right? Now the horizontal asymptote is just exactly from the back. So the horizontal asymptote is at y equals negative 4. So we're going to go to our graph, we're going to put those on, 1, 2, 3 for x. And negative 4 for y. So you see we move everything to the left and down on this one. And now what we're going to do is pick some nice x, y values. I'll walk you through that, and then I want you to pause the video and plug in whatever we get. We have our x, y chart. In the middle value here, we would do x equals negative 3 because we know that's something that's not allowed to be. Go a little lower, so go to negative 4. Then I like to skip by 2's. Go a little higher, so negative 2. Then I like to skip by 2's. Okay? Now I want you to pause the video, get your answers, compare them with mine. As you can see, our x, y values for this one are very close to each other. The reason for that is because our numerator was a 1. Alright, so we're going to do our best to get the best picture that we can see. Okay, so again, pause your video. If you need to copy my answers down or check yours, pause the video and let's plot. As you can see on this problem, do you see how quickly these ones start to turn? That happens as this numerator up top, like this negative 1, as the absolute value of that gets smaller and smaller and smaller, you're going to notice that it's going to start taking those turns really fast. So we're going to have to do our best to get the best estimate for the decimals. Just remember that you see the side I'm tracing right now? That side is going to be mimicked as I begin to go down. So get them plotted, pause the video if you need to catch up. So what do you think? Do you feel like you understand that you know how to move the asymptotes up and down and left and right? Let's give you 2 more examples to see if you could identify the asymptotes of an equation. Let's give you the example, y equals, let's do 2 over x plus 1 plus 3 in the back. Why don't you guys try to identify what you think the asymptotes would be? You should be telling me that the vertical asymptote is where x equals negative 1. Because remember, your denominator should never be negative 1. So that's where your vertical asymptote will be. You should also be telling me that the horizontal asymptote should be at y equals a positive 3. So those are the 2 values that your graph will approach but never touch. Let's try a couple more. What about y equals negative 3 over x minus 1 minus 4? Well, you should tell me that there's a vertical asymptote where x equals a positive 1 this time. Since x shouldn't be positive 1, that indicates that there should be a vertical asymptote there. And there should be a horizontal asymptote where y equals negative 4. Alright, go ahead and study that a little more if you're not understanding. And let's go ahead and apply this to a real-life situation equation. Let's apply this to a word problem. Dancing. Your dance club sponsors a contest at a local reception hall. Reserving a private room costs $350, and the cost will be divided equally among the people who enter the contest. Each person also pays a $30 entrance fee. What is an equation for the total cost per person of entering the contest as a function of the number of people X who enter the contest? Alright, so they're asking us to find an equation for the total cost of a person. So we'll do Y equals, and remember, that's the total cost per person. Now let's think to ourselves what's being divided. So we all have to pay for this hall. This hall is $350. But not just one person is going to pay that $350. That's going to be split up by how many people enter the contest. So if there's, 70 people, that's going to be split up that way. If there's 10 people, it's going to be split up among those 10 people. In addition, you have to pay $30 for entering. So we have the total cost as being the shared fee of $350 among how many ever people come, plus they have to pay that $30. Part B. What is the graph of the function of part A? Y equals 350 over x plus 30. We're going to use the graph to describe the change in the cost per person as the number of people who enter the contest increases. Now what we need to do is we need to do this on our TI 83s or 84s together. So we're going to do this on the TI calculators when we come back to school. I'm also going to teach you how to approximate values on your calculator. It says approximately how many people must enter the contest in order for the total cost to be about 50. What we're going to do is you're going to learn how to do this. We'll learn this together, how to do this on your calculator. Okay? But what I want to do with you is make sure you understand how to do this algebraically. So we want the total cost per person to be 50. So that means in our equation, y is going to be 50. So we're going to say we want the total cost to be $50. Well, then that has to equal the $350 divided evenly among how many ever people come, plus the $30. The first thing we do is subtract 30 and get 20 equals 350 over x. Now we're going to multiply both sides here by x and get 20x equals 350. Now you're going to take your calculator and you're going to divide 350 divided by 20. And I get 17.5. Now remember, x is how many people come. Now we don't want 17 and a half people coming. You don't want a little half body running around. So we're going to say that we're going to estimate up to we need 18 people to attend in order for the cost to be about $50. Problem 4, got it. In problem 4, suppose that the cost to rent a private room increases to $400. Approximately how many people must enter the contest now in order for the cost to be $50? So nothing's changing except for the fact that we're going to do 400 divided equally among those people, plus the registration fee. So again, I can teach you how to do this on your calculator with a new equation, but algebraically, we kind of find out it's not too bad, is it? You just do 50 equals 400 divided by x plus 30 minus 30, so you get 20 equals 400 over x, multiply by x, so 20x equals 400, divide now, 400 divided by 20 is 20, so you can say, nice and even answer here, you need 20 people to be able to go into this contest so that the price will be about $50. The back page is kind of neat because it's shown you a lot of the different ways and a lot of different graphs that you've studied, which is neat to see that all of your learning is kind of coming to an end here that you're going to be able to really use in the coming courses that you have. So let's take a look at some of the difference. you learned most basically, and this was in chapter 5, you learned about y equals mx plus b. Those are straight lines. Then you and I moved to chapter 9 together. And in chapter 9, you guys learned about quadratic equations. We learned that they're called parabolas. And they have that formula. And you learned how to graph those. Remember how you had to do negative b over 2a? Okay. We will talk about absolute value functions. Now, whether you remember absolute value functions or not, those were taught to you back in chapter 5. If you feel like maybe you want a review of those, please let me know, because I wasn't with you when you studied those. You also learned about exponential functions. We did this one together. Not quite sure what chapter it was. I do believe it was chapter 7 or chapter 8. And then we moved on to square root problems. And that was, again, I think that was in chapter 10. I do know that one. So can you see how everything that we've kind of learned, it's all kind of coming together. And then this one we finalized in chapter 11. So it's neat how you can kind of see everything coming together in the different equations that you've learned. In chapter 10, you learned how to move things left and right and up and down. Well, so you did in chapter 11. You did in chapter 5. You learned how to move things up and down here. You learned how to move things up and down with parabolas. So I'm hoping that you can kind of see that you've really learned a lot of different concepts. Each one has a different beginning, and each different beginning kind of tells you what the graph should look like. So today you learned about inverses. Alright, go ahead and finish up your lesson, and we'll talk about how to use your calculator to help you a little bit with those other problems.